Hi, in this class we'll be learning how we find log and antilog for a particular number. Now what log tells us is the representation of a number in terms of power of 10. To give you an example, let's say if I have 100, 100 is which power of 10? So you will say it is 10 raised to power 2. That means log 100 is 2. Log is converting a number into its power of 10. Now, likewise, if you have 1000, it is 10 raised to power 3. So, log 1000 will be equal to 3. Henceforth, you can have log 10,000 as 4. Same way, if I ask 1 is which power of 10, so you'll say it is 10 raised to power 0. Likewise, 10 is which power of 10? It is 10 raised to power 1. So you have log 1 as 0 and log 10 as 1. Now these two we have to keep in mind to find log of any other number. Just remember log 1 is 0 and log 10 is 1. Now if you have any number which is less than 1, let's say you have log of 0.1, I can say 0.1 is 1 by 10 or it is 10 raised to power minus 1. So log of 0.1 will be minus 1. Log of 0.01 will be equal to minus 2. So on and so forth. Now these were simple numbers, all can be represented in direct powers of 10. But now if I say 7.2 and I have to write in terms of 10 raised to power, what is 7.2? So you cannot give me the direct answer to this x. For this you'll be using log tables, and whenever we have to find a log of a particular number, we will convert that number in the format of a dot b c d. So you have a, b forming the number, c, d forming column and difference. Now if you have any number, say you have 379.8, you are not going to directly find the log of this number. You will convert this into 3.798 into 10 raised to power 2. Now you will find the log of this number. These two, a and b, form the number, c forms the column, and d forms the mean difference. So the most important thing that you have to remember, whenever you have to find a log of a particular number, it may be greater than 10 or 1000 or million or anything, or less than 1 or anything, you just convert that number in the format of a dot bcd, where ab will form that number, c will form the column, and d will form the difference. If you have this number in this format, this number will be more than 1 and it will be less than 10. So your answer will always be between 0 and 1. So just make sure that the number which is given to you becomes greater than 1 and less than 10. So the correct format would be A dot BCD. Now let's try and use this in log tables. Let's say I have to find log 7.2, which means 10 has to be raised to which power to get 7.2. If you look at this format A dot BCD, this will be 72. You have no column and no difference. So you will go to log table. So in front of 72, this is the column. So you have 0, 1, 2, 3. These are the columns, 4, 5, 6 till 9. And this small numbers over here, these are the mean difference column. Now, so you have 72. So you look in column number 0, which will be 8573. So nothing has to be added. So you'll say log 7.2 is 8573. Whatever you're looking in log table, just put a point over here. So your answer would be 0.8573. The reason, log 1 is 0 and log 10 is 1. 7.2 is less than 10. So your answer has to be less than 1. So just put a point. So your answer is 0.8573. And mathematically what it means, if 10 is raised to 0.8573, this power, it will give us 7.2. Now, likewise, let's say I have to find the log of 3.798. So this will be your number, this will be the column, and this will be the mean difference. 3.798. So you look in 37. 37. Column number 9, which will be 5, 7, 8, 6. So 37, column number 9, and mean difference of 8. So mean difference is the last. This is the entire thing is for the column, and this entire thing is for mean difference. So you look at under 8 for 37. So that will be the value will be this much, 9. So this you saw 37. In column number 9 you had 5786. Now mean difference is 9. You add 9 to this. So it becomes 5, 7, 9, 5. 5, 7, 9, 5. So 5, 7, 9, 5. You just put a point over here. So your answer would be 0.5795. Likewise, let's say if I have to find the log of 234.9. So first I will convert this into the format of A.BCD. So we'll write log of 2.349 into 10 raised to power 2. Since log converts number into power of 10, and when powers of 10 are multiplied, in fact you add them. So I'll find the log of this. This will become plus, and 10 raised to power 2 has a log of 2. When numbers are multiplied, powers are added. So we will look in 23, column number 4 and mean difference of 9. It will be point something plus 2. So even before solving this, I know my answer will be 2 point something. Now 23, so you have 23, this is 0 column, this is 1, this is 2, 3 and 4. In fourth column you have, so for 23 in column number 4 you have 3, 6, 9, 2, and you have to look in the mean difference of 9. So last column of mean difference, that is given as 17. So you will add 17 to this. So it will be 9, 0, 7, 3. So 3709. So we put over here it's 0.3709. So our answer will be 2.3709. This is the log of this number. Now come to think of it, when we started the topic, if you have log 100, it will be 2. If you have log 1000, it will be 3. This number 234.9 is in between 100 and 1000. So our answer of log has to be between 2 and 3. So you're getting an answer which is between 2 and 3. So you can always check your answer. Just this format has to be kept in mind. Whether the number is greater or less, just convert into a.pcd. AB will be the number, C will be the column, and D will be the difference. And whatever your answer, put a point before that. Point X, Y, W, Z. This becomes your answer. Now we'll practice one more. And I will suggest that once I write the number, you try and do it on your own. And later on, you verify your answer. You can pause the video and you can just verify the answer later on. Now, let's say we try and find the log of 126.8. So first of all, I'll convert this into the format of this 10 raised to power 2, the log will be 2. Now I have to look at number 12, column number 6 and mean difference of 8. Number 12, column number 6 and mean difference of 8. If you're looking some numbers, you have two columns, one on the upside and one on the downside. If you're looking at the column which is on the downside, then you will add the mean difference which is on the downside. So 12, column number 6 which is on the downside, so the mean difference will be 27. Had I looked for something like 12, column number 4, I would have used the mean difference which is on the upside. So in this case, it is 1004, which is 12, column number 6, and 27 you add to this, it will become 1031. So your answer would be 0.1031. So it will be 2.1031. Should be your answer. Again, 126.8 is in between 100 and 1000. So our answer should have been between 2 and 3. So it is 2 point something, which is correct. So 12, 12, number, 6 column, and 27 as mean difference. Whatever your answer, just put a point in front of that. Now we'll try and find log of a number which is less than 1. Log 1 is 0. So if we have a number which is less than 1, we'll start getting negative answers. So let's try and do it for, let's say we have to find log of 0.00285. Let's see if to find the log of this. Again, we will convert this into a format of A dot B C D. That would mean 1 place, 2 place, and 3 place. So I will rewrite this and say this is 2.85 into 10 raised to power minus 3. I have to come 3 times from my right towards my left. So I'll put minus sign, minus 3. So this would be the number 28 and 5 will be the column. There is no mean difference. Plus 10 raised to power minus 3 will have a log of minus 3. So 28, column number 5. So this is column number 5 and 28. This is 0, 1, 2, 3, 4, 5. 4, 5, 4, 8. So it will be 0.4548. So you subtract 3 from this. 0.4548 minus 3. So it will be 2, 5, 4, 5.2 negative. So our answer will be minus 2.5452. We are getting our answer in negative. Now let's compare this. 10 is to power minus 3, and if you have 10 is to power minus 4, this case it will be minus 3, this case it will be minus 4. 10 is to power minus 2, it will be minus 2. This number which was given to you was something into 10 is to power minus 3. So minus 3, this number was greater than 10 to the power minus 3 because something into 10 to minus, but it was less than 10 to the power minus 2. So your answer would be between minus 2 and minus 3. You're getting a negative answer because you are finding a log of a number which is less than 1. We'll try one more case. Let's say we have to find log of 0.04142. To find the log of this, we'll convert this into log of 1, 2. So I have to come 2 places from my right to left. It will be 4.142. 4.142 into 10 raised to power minus 2. This will be number, this will be column, and this will be difference. 41, column number 4, difference of 2. So 41. Column number 0, 1, 2, 3, 4. Column number 4 you have 6170, and you have mean difference of 2. So it also has 2 as mean difference. So add 2, 6172. So 6172, so it is 6172 point minus 2. 10 is to the power minus 2, the log will be minus 2. So our answer will be, we subtract minus 2 from this, 8 2 8 3.1 negative. So minus 1.3828. This will be our answer. I hope this is clear. So we can find the log of a number which is greater than 10, in between 1 and 10, or less than. So you just have to follow this format. This should be clear. Convert into format A dot BCD. AB will be number, C will be column, and D will be the difference. Now, when we come to antilog, what antilog does, it is just the opposite. Antilog is converting power of 10 back to number. So it is just the opposite of log. So if A dot BCD, the log, when you see the log, it is 0.xywz. When you see the antilog of 0.xywz, it should give you back A dot BCD. Antilog is converting this power of 10 back to the number. So antilog starts after the point. This xy will be the number, w will be the column, and z will be the mean difference when you look at the table of the antilog. Same logic, but this time the number will be after the point, then the column, and then there will be the difference. So what we'll do, we'll take a number, we'll find the log, and then we'll find the antilog, and we should get back the number. Now let's say we have six point 456. Find log of this. So this is already in the correct format of A dot BCD. So this will be the number, this will be the column, and this will be the mean difference. So 64. Column number 0, 1, 2, 3, 4, 5. It is 8096, and the mean difference of 6, 1, 2, 3, 4, 5, 6. So we have 4, 4, which is 8100. This comes out to be 0.8100. It can be simply written as 0.81. So this is the log of 6.456. Now if I find anti-log of this, I should get back the number. The only case is you can have one difference. The last decimal, instead of 6 you can have 5 or 7, but you should be able to recover the number. Antilog point x, y, w, z. In antilog, after the decimal point, the first two will make the number, then column, and then difference. So after decimal point you only have 81. So in antilog table, you'll go to 81. So you have, in column number 0, you have 6, 4, 5, 7. So you have 6, 4, 5, 7. Whatever you see in antilog, you write as A dot BCD. That means if you have seen 6, 4, 5, 7, you will write it as 6.457. Now, we started with this, we have got this. There will be slight one decimal point, one number at a last decimal point that may be different. In some cases it will be same, in some cases it will be different. That shouldn't be a problem. We'll try one more thing. Let's say find log of 4.712. So 47, 1 column, 2 difference. 47, column number 0, column number 1. So this is 6730, and difference of 2, you add 2. This is 6732. 6732. So this is 6732 point. So the log of 4.712 is 0.6732. This was in this format. Now the answer is this format, and we'll see the anti-log. Our answer should be A dot BCD. So in anti-log, you will go to 67, column number 3, and mean difference of 2. 67, so you have column number 0, 1, 2, 3, and mean difference of 2, you have 2. So 4710 plus 2 will be 4712. 4712. So this will be 4712. And whatever you see in anti-log, you put a decimal after one number. So it will be 4.712. I hope this is clear. Anti-log starts after the point. First two are numbers, then the column and the difference. Now we'll take some numbers which are larger than 10. Let's say we have 5 62.9. We'll try and find log of this, and then we'll check our answer with antilog. So for finding log, first you'll put it in correct a.bcd format. Since you are lowering the number, the positive power of 10, so 5.629 will be 5.62, 562.9 will be 5.629 times to the power 2. Now you look in 56, column number 2, mean difference of 9. 56, column number 012, mean difference of 9, you have 7. So 7497 plus 7. So it will be 7504. 7504 point, and plus 10 to the power 2 will have log of 2. So the final answer, log of this will be 2.7504. Now if I see the anti-log of this number, I should recover my number. Anti-log starts after the point. So you will go to 75, column number 0, and mean difference of 4 in anti-log table. "75, column number 0, and mean difference of 4. So that will be 5. So you have 5, 6, 2, 3 plus 5. So it will be 5, 6, 2, 8. 5, 6, 2, 8. And this 2 is directly 10 to the power 2. Whatever is before the decimal is direct power of 10. So I started with 562.9 and I ended with 562.8. You can have 1 point, last number, it can be either one more or one less, but more or less we get the same number back. Now we'll try one more case. Let's say we have to find log of 7, 8.78. So we'll convert this into 7.878 into 10 raised to the power 1. So in log table should be the format 78, column number 7, 0, 1, 2, 3, 4, 5, 6, 7, and mean difference of 8. So you have 8, 9, 6, 0 plus 4. So 8, 9, 6, 4. 8, 9, 6, 4. 8, 9, 6, 4 point plus 1. So this is 1.8964. Actually, you have found the log of this to be this. This is the place where you use the table. Actually, if the log table that you have used is only to find the log of this to this. This 1 is only the power of 10. So if you find the anti-log of this, you should recover the number. So anti-log will start after the point. So 89, column number 6, mean difference of 4. 89, column number 6, 0, 1, 2, 3, 4, 5, 6, and mean difference of 4. So it will be 7870 plus 7, 7877. So I write this as 7877. Point over here, because when you find anti-log, the point has to be after, and this 1 will be into 10 raised to power 1. So you have 78.77. So in short, whenever you are finding anti-log, anything before the decimal is simply power of 10, and you find the anti-log of numbers after the decimal point. Now, this was the case where we are taking positive. Now, let's take the example of some numbers which are smaller than 1, because once we take their log, we will get a negative value. And how do we take anti-log of a negative number? Now, let's say you have to find the log of 0.0004255. First of all, I'll convert this into a dot BCD. So 1, 2, 3, 4. I can rewrite this as 4.255 into 10 is to power minus 4. So basically I have to take the log of this number. So it will be 42, fifth column, 5 as mean difference. So 42, fifth column, 0, 1, 2, 3, 4, 5. And 5 of mean difference, we only have 5. So it will be 6, 2, 8, 9. 6, 2, 8, 9. So 6, 2, 8, 9. Point minus 4. So you end up with, you have to separate 4 from this. We will have 1, 1, 7, 3.3 negative. This will be your answer to log. Now let's say I have to find the antilog of this. If I have to find antilog of this, I should be able to recover the original number. The problem with finding antilog of negative numbers is that you may raise 10 to any power, you cannot get a negative number. So we have actually looked at log of this, which is this. 6289 was what we looked in the log table, but it has become 3711 because we subtracted 4. So you must remember that you cannot directly find the antilog of a negative number because that value has changed due to subtraction. The value does not change when you add something. Let's say if you have 0.6289 and you added 4, this wouldn't change. This will become 4.6289. So again you will find the antilog of this, there will be no problem. But when you subtract, this value changes. Now to find the antilog of a negative number, you add one larger number to this. So if you have to find antilog of this, we will say plus 4 and minus 4. So first we will add 4 to this. When you add 4 to this, you get 0.6289. You can add 4 to this, you will get this. And when you subtract this 4, you write it as 4 bar. Bar is indicating negative power of 10. So for finding antilog of negative number, it cannot be done directly. First you have to add one larger positive number. So it was minus 3 point something, so I added 4, and when I'm subtracting 4, I'll put it as 4 bar. Now in antilog, you will go to 62, column number 8, difference of 9. 62, column number 8, difference of 9. So 4 to 4, 6, you add 9, becomes 4255. 4255. So this is 4255. Whatever we look in antilog, we put a point. So it becomes 4.255 into 10 is to power. Bar means negative power of 10. So this is what our answer will be. And if you look at what we started with this and we have recovered this. Negative, you do not find antilog directly. We'll try one more case. We'll find log and antilog, and then we'll do an exercise where we only find logs or antilogs of given numbers. I'm finding both log and antilog just to tell you that you're getting the same answer, but you only have to find one in your exam. You don't have to give log and antilog, both the things. Now let's say you have point 0.3737 to find log, and then we'll find antilog to this. So for finding log, 1 to 3.737. This 37 number, column and difference. So 37 column number 0, 1, 2, 3, 5, 7, 1, 7, and in 7 you have column number 7 you have 8. So we add 8 to this, becomes 5725. 57. So 5725. We put a point. This to this into 10 raised to power minus 2, minus 2, 5, 7, 2, 4.1 negative. This is our final answer. Log of 0.03737. First we converted to this format, subtracted 2. This is our final answer. Now if we have to find anti-log of this, we cannot do this directly. It is a negative number, so we'll add one greater positive number. So anti-log of this, if you have to find, first of all you should know you'll get this number back. But how you're getting this back, the value that you saw in log has changed, so you'll recover that value. How you recover? Whatever negative number you're given, you add one larger number to that and subtract that number. So this plus 2 minus 2. So first we solve this. 2 minus 1.4275, if you add 2, you will get 0.5725, and this minus 2 will be written as 2 bar. Now we'll look at anti-log of 57, column number 2, difference of 5. 57, column number 2, difference of 5. So this we add up, 3733 plus 4. So it will be 3737. So it will be 3737. When you look at anti-log, the decimal has to be after one number. So this will be this. And bar would mean 10 raised to power minus 2. This should be your answer. And I think this is what we started with. We have recovered the number. So just remember, if it is a positive number and you're finding anti-log, do nothing. If I give you 2.88 and you to find anti-log, just find the anti-log of 0.88, put it in the format of a dot bcd and into 10 raised to power 2. But if I give you minus 2.88, you cannot find it directly. You will add 3 and subtract 3. When you add 3 to this, it becomes 0.12. When you subtract 3, it becomes 3 bar. So you look at anti-log of 0.12, put it in the format of a.bcd, and bar would mean 10 raised to power minus 3. Just this has to be kept in mind. Now I'll give some numbers, and first we'll find some logs of some numbers and anti-logs. You try this exercise, pause the video, and once you're through, then you just play it on and look at the answers. So let's say we find log of 42.9 into 10 raised to power 12, log of 0.00005, and log of 0.032 into 10 raised to power minus 13. We have to find log of these numbers, and we have to find antilog of minus 4.15 antilog of plus 4.15 antilog of 203.7 antilog of 0. So these 7 questions have to be practiced. I'll just start solving them. The first one, when you're finding log, the format has to be a dot bcd. So the first one I'll put it as 4.29. It becomes 10 to the power 13. So I have my answer is something plus 13. So my answer will be 13 point something. So to find that, I'll go to 42 column number 9. 42 column number 9, 6325, 6325. So you have 6325 point. So your answer will be 13.6325. 42.9 is to be written as 4.29 into 10 to the power 13. Instead of 12, it will become 13. So you go to 42 in log table and column number 9. This should be your answer, 6325. The second one is 0.4 zeros and 5. So 1, 2, 3, 4, 5. To go 5 times from my right towards my left, so I can write it as 5.5 into 10 raised to the power minus 5. So 10 raised to the power minus 5, the log will directly be minus 5. So I have to find the log of 5.5, which will be 55 in column number 0, which will be 7404. 7404. So it will be 0.7404 minus 5. So the answer will be negative. It will be 6952.4 negative. So something minus 5. My answer has to be minus 4 point something. I hope this is clear. Next one, it is already minus 13. So you go 1, 2. So it will be 3.2 into 10 to the power minus 15. So I look at log minus 15. 10 to the minus 15, log as it is will be minus 15. So 3.2, that means I'll go to 32 log table. In 32 you have 5051, 5051 point minus 15. So the answer will be 9494.14 minus. So minus 14.4949. This should be your answer. So all the 3 logs have been solved. We'll come to antilog. In first case, in antilog we have a negative number. We cannot find the antilog of a negative number. So you add one larger number to this. So we'll have to add 5 to this. It'll become 0.85. And when you subtract 5, it'll become 5 bar. So you look at antilog of 0.85. That will be 7079. 7079, which will be written as 7.079 into 10 to the power minus 5. Bar means negative power of 10. So you just looked at antilog table in front of 85 7079. Finding antilog of 4.15, you don't have to do anything. This is positive, so this directly means into 10 to the power 4. So look at antilog of 15, which will be 1413. 1413. So write your answer as 1.413 into 10 to the power 4. Now antilog of 203.7. Antilog starts after point. Whatever is over here, it is power of 10. If it is negative, then you have to add one larger positive number. This is not negative. So my answer would be 10 raised to power 203. Now I'll just look at antilog for 70.70. That will be 5012. So this can be written as 5012 can be written as 5.012 into 10 to the power 203. This should be your answer. Now the last one is antilog of 0. A lot of students get confused in this. Log 1 is 0. If log 1 is 0, you say taking antilog on both sides. Log and antilog will get cancelled. Antilog of 0 is 1. Likewise, antilog of 1 will be equal to 10. Log 10 is 1. So taking antilog, take log to this side. So antilog of 1 will be equal to 10. Likewise, antilog of 3 will be equal to 10 to the power 3, which will be equal to 1000. This is precisely what I have told you. Antilog converts power of 10 back to number. So if 10 to the power 3, if I convert it into number, it will become 1000. So I hope this lesson is clear. You will require some practice. Take few numbers, find their logs and antilogs. Your answer should come back. That number should be recovered. And in case you have any doubts, you can personally ask me in class. Thank you.